So you start your Honda tractor, it runs for a few minutes, then it dies and restarts normally. And it may run for another few minutes and die, or it may continue running. Well, what I want to do is address that problem in this video. The fuel control module in these tractors is designed to eliminate the manual fuel control valve, so you don't need to keep turning it off when you switch the tractor off. This diagram illustrates how that valve works. When you switch the ignition key on, 12 volts is applied to the fuel hold coil through a 3-input OR gate for about 20 seconds. When you go to start, the 12 volts is applied to the activation coil through the 3-input AND gate, of course, for about 1 second. This allows the whole coil to keep the valve open. The engine then starts, and the charging coil detector injects a third signal into the OR gate that will keep the 12 volts applied to the whole coil and keep the valve open for as long as the tractor is running, hopefully. If the engine is not running, the fuel valve closes after about 20 seconds. Now, the RPM detector is part of the fuel control module that seems to be intermittent, possibly because the shunt regulator is reducing the charging coil output to the RPM detector. If the RPM detector does not function, the fuel valve will close within 25 seconds and the tractor will run out of the fuel left in the carburetor within about 10 seconds. Cycling the key starts the process all over again, so the engine starts and runs normally until the fuel bowl runs. So here's a few pictorial diagrams from the manual that might help you understand the circuit a little bit better. Here's a pictorial diagram of the complete fuel control module and the fuel valve. And then secondly, here's a modified diagram of just the fuel valve showing the connector with the center wire being blue and white that goes to the activation coil. I've taken some photos of the fuel valve in the tractor, and here they are, several different views of it so you can see what it looks like, and it's physically located just underneath the headlight. In the video that follows, we're going to be injecting 3 volts into the RPM detector of the fuel control module to verify the operation of the whole circuit once the engine is running. Here's a diagram of where that 2-pole connector is on the engine. We disconnected it from the actual charging coils and we'll inject 3 volts into the coil to see if the circuit is functioning properly.
So let's look at the setup here. What I've done is I've disconnected the charging coils and hooked them to a battery that's essentially got 3 volts on it out of an old Harbor Freight flashlight. And the meter, the voltage meter, is hooked to ground and to the center pin on the fuel control valve, which I believe is blue and yellow. It's not the activator coil, but it's the hold coil. So what I'm going to do is I'm just going to turn the ignition on, and you can see that the coil did come on, 12.6 volts, and it'll stay there for about 30 seconds and then go off unless the logic detects that the engine is running from pulses coming from the charging coil. And I believe this is the problem with most Honda tractors. There you can see that it dropped to 0 volts. Now what I'm going to do is I'm going to apply just 3 volts from the battery and see if it does anything. In this case it did not, which means something may not be working. Okay? Something happened in the regulator that allowed me to touch this battery voltage to here and click it on. Now it's stopped. There we go. See, it went on with the actuator there. Goes off. Goes back on. Now there's a slight delay. Now if we turn the key off, turn the key back on, and we'll see if this voltage stays there for more than 30 seconds. If it does, then the battery's taking effect here. And I'll disconnect the battery just to give you an example. Okay, see, it went away. comes back on. So slight delay for that thing to charge up. Now that's how the circuit should be working, and it will hold voltage on there all the time. Sometimes it works, sometimes it doesn't. Now we reverse the polarity on this. Okay, it came back on. That's how it should work, to hold 12 volts on that fuel relay all the time. Sometimes it works, sometimes it does not.
Here's the fuel control workaround. What we need to do is apply 12 volts DC constantly to the whole coil of the fuel valve so it stays open while the tractor's running. So what I did was I added 2 wires to the tractor. One that detects the plus 12 volts ignition on at the fuel fuse, number 2 in the fuse block. The second wire goes to the hold coil, which is the blue and white center wire at the fuel valve connector. And a simple 100 ohm resistor and a blocking diode can be connected in between these 2 wires, and the fuel valve will remain open as long as the engine switch is on, and start was activated, of course, to turn on the coil. To maintain the original design, however, that closes the fuel valve when the engine is not running or the engine stalls, I've designed a special circuit that detects the battery charging, basically when the voltage is over 13.5 volts, that can be connected between these 2 wires. The circuit will drop the voltage to the fuel hold coil when the engine is no longer. Look at the circuit and you can see the insertion point for either the 100 ohm resistor with the blocking diode or the battery charging detector for plus 12 volt ignition, and to the center wire of the fuel valve, which is the blue and white wire. These photos show the modifications to the 3-pole connector that connects to the fuel valve. First of all, we pulled the center connector out, we soldered a wire to it, and then we put heat shrink around the connector and stuffed it back into the plastic housing. Then, for the plus 12 volts ignition, what we did was we tapped the fuel control module fuse at the top side of the fuse, which goes through the fuse. Here's an alternate phantom type connector that you can use in place of soldering the system and connecting to the fuse. It must be connected into the wires in the system itself. Here's the series resistor and the blocking diode construction. Notice I used 2 spade connectors and some heat shrink to mark the positive end of the system. Now you can also insert a 500 ohm resistor in here without the diode, and that will keep 2 volts on the fuel valve. This circuit will keep about 6 volts on the fuel valve.
Let's take a look at what I did on the whole circuit. Here is the 500 ohm resistor. It goes to the middle wire on the fuel valve to the fuel fuse of 12 volts. Okay, so what we're doing is we're running 12 volts when the ignition's on to hold that valve on. 500 ohms, 100 ohm for the coil itself. I may measure that coil again just to see.
Let's take a look at the comparator circuit that detects the battery charging, that will essentially emulate what the tractor did and shut the fuel valve off if the engine stalls. We've got, here are the insertion points, then we've got a circuit for the comparator, and finally I've got you a list of resistor values so you can use virtually any zener that you want to turn the circuit on at about 13 to 13.5 volts. The video that follows shows how the circuit works.
Okay, I wanted to give you some idea as to how this circuit is supposed to function. So here we got the voltmeters. This meter is reading the output voltage, which would ultimately go to the fuel control valve, and this meter is reading the battery voltage. So if we vary the battery voltage down between where our battery would normally go, between 12 volts, and let's go up to, keep going up, keep going up, keep going up. Nothing's happening, and you'll see that eventually at the trigger point There it is. You see we get an output of about 12 volts, which will definitely hold the fuel valve open. So when the battery voltage drops back down, that voltage drops to a very small amount, which will not do anything with the fuel valve. So if you turn the key on in the tractor and the battery voltage stays below 13 volts, the fuel valve will stay off after the 20-second timer, of course. If the alternator is running and the battery is above 12 volts, or 13 volts, let's say, which it should be, let's bring it up to 14 or 15, you see we get enough voltage on the fuel control valve to make sure that that it will stay open. So
I built a comparator circuit on perf board, then I wrapped it with shrink wrap and a little bit of RTV and double shrink wrapped it, and then I mounted it on the tractor near the headlight and connected it in series where the 100 ohm resistor would be otherwise. Okay, let's start her up. Okay, now we'll wait for that alternator to kick in. You can see the fuel valve just went off. And there we are. The main alternator did not kick the fuel valve on, so the auxiliary circuit is now running it at basically half the voltage. Now the tractor kicked in.